All right. Hi. Today we are going to be reviewing our angle pairs unit, our relationships, our angle relationships units, and our 3D ratios. Okay. These are the areas that we were struggling on a bit from our practice SOL. They're also very big units on our actual SOL, so we need to make sure we're understanding the topics. After today, you can definitely take one of these retakes either in class or sometime next week. You can sign up for Bear Block. So first, let's look at some angle pairs and what we need to know about angle pairs. If we have congruent angles, okay, they are going to be vertical angles. Those will always be equal, but they do not prove things to be parallel. Okay, they are congruent, but they do not prove to be parallel. Okay, so they do not prove things to be parallel. Alternate interior angles, alternate exterior angles, and corresponding angles will most definitely prove things to be parallel. Okay, then we have our supplementary angles. Any linear pair you can find, such as 5 and 7, or any consecutive interior angles you can find, like 3 and 5, or 4 and 6. I should also have consecutive exterior on there, but I don't see it. So consecutive exterior, like measure angle 2 and 8. Okay, now if we can't remember our vocabulary, which sometimes we can't, the best thing to do on the picture is to add your X's and O's. Remember, it goes O, X, O, X, O, X, O, X, right? Where all of our X's are equal to X's, those are all angles that should be congruent. All of our O's equal our O's, and all of our X plus our O's will always be supplementary. Now remember, you need one of the 5 boxed items to prove something to be parallel. Okay, again, if you have information that is not on 2 different lines, it will never prove something to be parallel. All right, then we talked about the 3D ratios. That was later, that was in our 3D unit. Okay, we have that relationship of our scale factors. That's the A to the B. These are words like radius, length, perimeter, width. Then we have the area of our ratios, which is always going to be A squared to B squared. Then we have the ratio of our volumes, which will be A cubed to B cubed. Okay, sometimes they might ask us a question about the relationship, comparing specifically their ratio. So maybe they give us the volume and they want us to go backwards to our scale factor. Remember, if we're going from volume to scale factor, we have to take those cubed roots. Okay, if we're going from area to the scale factor, we have to take the square root. Now, if we're going the other direction, we have to take a squared. So if we're going from the scale factor, we take a squared or a cubed. Now, sometimes they ask us what happens if we triple or double something. That's when you're going to just plug things into an equation and see what happens. So say that we wonder what's going to happen to the volume of a sphere. And we've tripled the radius. So tripled radius, and we're looking at the volume of the sphere. Oops, there's an E there. Okay, so we're going to take the volume of a sphere, which is 4/3 pi r cubed, and we're going to put in the number 1. Okay, so we're going to get 4/3 pi 1 cubed, which is going to give us 4/3 pi, because 1 cubed is just 1, and 1 times anything is itself. Now they've asked us to triple this volume. So 1 times 3 is 3. So we're going to have 4/3 pi times 3 cubed. So we're going to have 4/3 pi times 27. Now, forgetting what we've now done up here, we are just looking at our answers. We have multiplied our original answer by 27 right here. That's the only thing we've multiplied extra. That's the answer they're looking for in a question like that. Okay? Always plug and chug. It's the best way to go. All right, so let's look at a few examples. So the diagram here represents the strips used to mark the parking spaces on a lot. Based only on the information given, I would like you to prove that AB is parallel to CD and AC is parallel to BD. Please realize that these lines here in the middle do stand for parallel. Okay, so that means we have to have information about both lines A and B and lines C and D, as well as AC and BD. So I'm going to highlight AC in one color for all my lines and BD in the same color because I'm trying to prove those parallel. Okay, just looking at A, B, and CD. So looking at one, do I have information on AC and BD? Yes, I do. Looking at B, do I have information on AC and BD? I do. Looking at C, do I have information on AC and BD? I do indeed. But looking at D, I don't have any information about AC. That one's gone. Okay, now I'm going to take my red and I'm going to do AB to CD. Okay, now I don't have any information on AB on A, so that goes away. Looking at B, again, I have no information on AB, so it's not helpful. C is the only one that gives me enough information to be helpful. So therefore, C would be my answer. Okay, we are going to not do that. So looking here, we have the figure that shows intersecting points. So these are parallel lines, JK and MN. So here's my parallel line, and here's a parallel line. And I'm going to say that here are my intersecting, is my transversal line. So if that's the case, and I put in my X's and O's in here, I realize that this X and this X are the same. So really, over here, I can fill out that this angle X is 3X plus 5. Now I have a triangle that has 3 angles in it. And how many degrees are in a triangle? There's 180. So I'm going to add everything up and set it equal to 180 degrees. And solve for my answer. If you would like to have more explanation on this problem, please ask me when I come back. I'm just going to quickly solve it and show you what the answer is. If you have a question on any of the steps, please ask me at a later time. All right, so there X would have equaled 25. All right, so we have again a walkway being diagonal to our 2 streets, which are parallel. So these are my parallel lines. This is my transversal. So I'm going to put in instantly, I see this X's and O's. That's honestly, every time I see parallel lines, I'm just putting in X's and O's and hoping that it's going to help me out somehow. All right, and I'm looking for what value could X be, which is right here. So again, I'm also seeing another triangle. So they're asking me to use multiple topics here. So O, right, and O. So if I knew what that O was, I could figure out what this O is. So I'm going to do 180 minus 132 to get my O, because I know my X is 132. So I'm going to get 8 and 4. So I'm going to get 48. Okay, as my O right here. And then I have a triangle, which is 90 degrees, and the corner, and 48, and I need my X. So I'm going to do 180 minus 90, which gives me 90, minus 48, which gives me 42. And so my answer here would be B. All right, this is a ratio problem. We have the height and the radius of a cone being multiplied by 3, and we're asked how does it affect the volume. So again, this is where I'm asking you to just plug in and see what happens. So if we're doing the volume of a cone, that's going to be 1/3 pi r squared h. Okay, and I'm going to plug in 1, so I'm going to have 1/3 pi 1 squared. Height is also 1 because we're multiplying the height and the radius by 3. So we get 1/3 pi. Now if I multiply 1 by 3, I'm going to get 3. So I'm going to get 1/3 pi 3 squared times 3. So I'm going to get 1/3 times pi times 3 squared, which is 9, times another 3 is 27. Okay, now looking at this, right here at the bottom, I multiplied the original formula by 27. So my answer here would be 27. Okay, the shortcut would be to take 3 and cube it, but this will always and forever work. We have 2 volumes of the sphere having a ratio of 1 to 8. So that means we are starting at that ratio of A3 to B3. And we are going to take the cube root of 1 and the cubed root of 8, which you can find in your calculators by going to Math 4. Okay, and we get 1 to 2, which gets us back at the regular ratio, which is exactly what we were looking for. So our answer is A. Okay, for this one, I would like you to please pause the video and try to solve it on your own after seeing these examples we've done together, and then see if your answer matches what I have. All right, so here we should have had the lengths of the radii is 1 to 3, and the ratio of the volumes is 1 to 27. So we get this by taking the square root of the ratio of their surface areas. And then to get the volume, we now take our original that we found here, and we square or cube both terms because it is volume. So we get 1 to 27. Again, I would like you to please pause the video and try this one on your own, and then see if you get what I get. Okay, so for our side lengths, you should have had 4 to 5. For our surface area, you should have had 6 to 25, because the volume was 64 to 125. So here we would have taken our calculators and done the cubed root of 64 to get this answer, and the cubed root of 125 to get this answer. And then you square these answers to get, so you square the 4 to get there, and you square the 5 to get to the 25. All right, so we also did a problem like this earlier. So please pause the video and see if you get the same answer that I do. So here you would have used the property of parallel lines as well as the triangle sum theorem to have gotten x to equal 14. Again, if you have questions about this, please star this example and I can talk to you when I return to school. All right. So two similar cones have the heights of 5 and 20. What is the ratio of their volumes? Go ahead and pause the video and see if you can figure out the answer to this one. Okay, so here we should have gotten B. I simplified first to make the math easier for me to do in my head. If you didn't simplify, you still would have gotten the same answer. You just had to simplify your bigger ratio that you'd gotten. So it would be 1 to 64. Remember, volume tells us we need to cube that original ratio that we had. Okay, so here we are told that if the radius of a circle is tripled, then the area of the circle is going to be multiplied by what? So again, this is that guess and check, so please give it a try. Okay, so here we would have gotten our answer to be 9. Notice that we multiplied by 9 when we plugged in the 1 and the 3. Okay, so from here, your assignment is to work on the 8 balls practice problems. Those are to be left in your folders that you received last class. They are not to become homework. You have to finish those in class.